This video will compare the procedure of approximation using both methods, linear approximation and differentials. Welcome to Differential Calculus. Before starting with some examples, let's summarize the main equations for both methods. In linear approximation, the equation is L of x, which stands for the linear approximation of a certain number, is equal to f of a plus f prime of a multiplied by x less a. Differentials, on the other hand, works with the concept of dy taken as f prime of x times dx, and dy is equal to delta y. The first example is to approximate the root of 110 using both methods, but we start with linear approximation. With the main equation for the method, identify x, which is the given number 110, and a is a number closest to the square of x. In this case, that would be 100. F of x is the root of x, so f of a is taken as the root of 100, which is 10. Getting back to the function of x, transform this into a rational exponent to use power rule easily when taking the derivative. The derivative of x raised to 1/2 is f prime, and this turns into 1/2 of x raised to negative 1/2, or taken as 1 all over 2 times the root of x. From this function, we can therefore take f prime of a as 1 all over 2 times the root of 100. From the main function, we take the linear approximation of 110 as 10 plus 1 upon twice of root of 100, and this is multiplied by 110 minus 100. This is simplified as 10 plus 1 over 2 times 10 multiplied by 10. And we get the approximate root of 110 as 10.5. The exact root of 110 is 10.4881, so the approximation is close to the exact answer. Now let's compare the procedure using differentials. The function used is with dy, and the function to be used is root of x, which can be written as x raised to 1/2. Its derivative is f prime of x, taken as 1/2 of x raised to negative 1/2. This can be written as 1 over 2 of root of x. So dy is 1 all over 2 times root of x times dx. X sub 1 for this example is 110, and x is 100. Again, x is the closest perfect square from x sub 1. Delta x is the difference of x's, which is 110 minus 100, taken as 10. This is dx. Delta y is the difference of functions, which becomes the root of 110 minus the root of 100, simplified as the root of 110 minus 10. Equating delta y with dy, we get the root of 110 minus 10 as equal to 1 over 2 root of x times dx. Plug x and dx, then transpose 10 to the other side to have the root of 110 as equal to 10 plus 1 over 2 times 10, multiplied by 10. This then gives the approximate value of the root of 110 as 10.5. Again, the exact root of 110 is 10.4881. Another example is to approximate the cube root of 195 through linear approximation. X is taken as 195, and a is the closest perfect cube from 195. that is 216. The function of x is the cube root of x, so the function of a is the cube root of 216, which is 6. The function of x is also written as x raised to 1/3, and its derivative is f prime of x, which can be computed as 1/3 of x raised to negative 2/3, also written as 1/3 times the cube root of x squared. F prime of a is 1/3 times the cube root of 216 squared. Using the linearization formula, we get the approximate cube root of 195 as 6 plus 1/3 times cube root of 216 squared times 195 minus 216. Have this simplified as 6 plus 1/3 times 36 multiplied by negative 21, which can be reduced to 5.8056. Compare this with the exact cube root of 195, which is 5.7989. This is close to the approximate cube root. Using differentials, we work with the same cube root of 195. To complete the general formula for dy, take the function of x as the cube root of x, also written as x raised to 1/3. F prime of x is its derivative, which becomes 1/3 of x raised to negative 2/3, also written as 1/3 times the cube root of x squared. This completes the dy equation. Then x sub 1 is 195. X is 216. This is the closest perfect cube from x sub 1. Next is delta x, which is 195 minus 216. This gives 21. This is also dx. Delta y, on the other hand, is the difference of the functions, and that is cube root of 216 minus the cube root of 195, which can be simplified as 6 minus the cube root of 195. Place all the parameters into the general equation of delta y as equal to dy. Place 6 minus the cube root of 195 is equal to 1/3 times the cube root of x squared multiplied by dx. The values of x and dx are placed to get 6 minus the cube root of 195 as equal to 1/3 times the cube root of 216 squared times 21. This is simplified as 6 minus the cube root of 195 as equal to 1/3 times 36 multiplied by 21. Transpose 6 to the opposite side to get negative cube root of 195 as equal to negative 6 plus 21 over 108, giving the approximate cube root of 195 as 209 over 36, which is 5.8056. As computed earlier, the exact cube root of 195 is 5.7989.